Hi guys, so this section, the main point that we're looking at is arc length versus inscribed angle. So this is looking at the arc IL and the arc KN. So what we know is, I'm just going to totally put a guess here. I'm going to say this angle degree is 40 degrees. That means this arc length would be 40 degrees. And because these are interior angles, but they're also vertical angles, this is 40, this would be 40, this would also be 40. So it's saying, is it possible to determine that these arc lengths are the same? And it is, because these are vertical angles. So if they're the same, the arc lengths are the same. True. Okay, so in triangle S, is it possible to determine that YX, let me get a different color, that this arc length is congruent to this arc length? So I'm going to go look. So that arc length is determined by these lines that make up this angle. So this angle is congruent to this angle because they're vertical. And so the arc lengths would be congruent. So that's true as well. And then the rest of these, I think they're just trying to get us to determine what the arc length would be. So let's look. So measure of ECD. So ECD, that would be 42 degrees. The measure of arc, FG, is 107 degrees. But remember, that is the same degree as the angle. Those match. And the measure of GCD is 90. That's a right angle. So we're trying to find the arc FE. So we want to find this whole arc. That's a lot. So we already know it's 107. We know this will be 90. And this will be 42 because the arc length is the same as the inscribed angle length. So we're just going to add those up to get our answer. So I'm just going to use Desmos to add these up. 107 plus 90 plus 42 is 239. So this whole arc length would be 239. But it's asking from FE, so right here. Okay, so we need to remember that around a circle is 360 degrees. So I'm going to subtract this 239. So 360 minus 239, 121. All right. So find the measure of arc MN. So I'm trying to find this measure. If the measure of angle KLM is 67. So if this is 67, then the arc length is 67 degrees. And I need to use my diameter here. I have a diameter that goes through the center. What that does is it cuts the circle in half. So remember, all the way around is 360 degrees. Oops. So half of that would be 180. So I know that 67 plus arc MN, which we sometimes see like this, would equal 180 degrees. So in order to find that arc length, I'm going to subtract 67. So 180 minus 67 is 113. That would be the arc length, 113 degrees. It would also be this angle, because these two angles are supplementary, and they have to add to 180, which we learned in quarter 2. So the measure of JLN is what we're trying to find if theta is 70. So if this is 70, then this angle is 70. And we're going to use what we did last time. These two angles are supplementary. They add to 180. So 180 minus 70 is 110. So this is 110 degrees, which means the arc length is 110 degrees as well. So 110. And I think we just get a couple like that over and over. Now we're trying to find the arc, MN, given the measure of K to L to M, theta, of 68. So if this is 68, the arc length is 68 degrees. And we know that the arc lengths and the two angles have to add to 180. So we're going to take 180 minus 68, which is 112. So this is 112, then the arc length is also 112. And those two things are supplementary. They add to 180. So that's it for this section. If you have more questions, ask me or Miss Hardy.